In this video, we're going to talk about Chebyshev's theorem. It's a lot like the empirical rule, but it works for any distribution. So the empirical rule was just for a bell-shaped curve. But for any distribution, you don't get as good of results as you do for the empirical rule, but you can still get something. So basically, Chebyshev's theorem says that for any value of k, then at least 1 minus 1 over k squared of the data is within k standard deviations of the mean. Oops, I can't spell. Within k standard deviations of the mean. So let's just plug a few values of k in to see what this means. If we kind of start at the beginning, k equals 1. Well, 1 over 1 minus 1 squared is 0. So yeah, at least 0% is within 1 standard deviation of the mean. So that doesn't really say anything. Let's try 2. So 1 minus 1 over 2 squared. 1 over 2 squared is a fourth. 1 minus a fourth is 3/4, which is 75%. So for any distribution, 75% of the data is within 2 standard deviations of the mean. Okay, that seems useful. Not nearly as good as the 95% that we had for just the bell curve. But again, the power of Chebyshev's theorem is it works for any distribution whatsoever. Let's do a couple more just to see how far we need to go. Well, if k equals 3, 1 minus 1 over 3 squared. 3 squared is 9, so we've got 8/9, which is 88.9% within 3 deviations of the mean. And let's go one more. Let's go 4. 4 squared is 16, so that's 15/16, also known as 93.75%. So within 4 deviations. So for arbitrary distributions, we're starting to get kind of close to that 95% we had for a normal distribution. But basically all Chebyshev's theorem says is that for any distribution, this formula that we came up with for standard deviation, it does what we want it to. It really does predict how close things are to the mean. So anyway, that's really about all I want to say about that, because again, we're not going to really use Chebyshev's result in this class. If you do there are statistical methods based on Chebyshev's theorem if you want to make confidence intervals for things that aren't normal distributions or t-distributions or all the things we're going to work with in this class. If you know nothing of the shape of the distribution and you don't want to use the central limit theorem to pass to sample means or something, then really Chebyshev's theorem is kind of the best you can do. So it does have its uses, but I mean, just to point out, these bounds, these percentages are not nearly as good as what we were getting for the empirical rule. So This is kind of when you have nothing else to work with, use Chebyshev's theorem. But it is important for theory purposes because it tells us that this formula we wrote down for standard deviation, it really does do what we wanted it to do. It tells you how far spread out is your data from the mean.